Hey class, I wanted to send a video demonstrating concatenation versus the join method. There's advantages to both. Concatenation is easy. We understand it. It's something we learned in our basic course and we've used left and right. However, concatenation comes at a cost. There is a processing tax, so to speak, when we use concatenation, especially in a loop. And that's because Python will create individual strings for each iteration through the loop and never destroy those strings until either the program ends and we get automatic garbage collection that happens upon close, or unless we go and do some more manual. And we tend not to do that. So in small programs like ours, that we had in 140 and now that we'll have in 240, honestly, it won't make much of a difference. But when you get to data analytics and some big data where you're going to have a million of these happening, well, every time a string is created and carried, that burden is going to be cumulative and really impact performance. Now, as an alternate, the Python join method will accomplish the same task in that it will essentially concatenate a list together, except it does so without creating strings. It will just do really one sort of final string, and that's a pretty cheap processing load for that. So here's just some code explaining the join method. First of all, here is a very simple script, and this is right out of the book. And this demonstrates, and let me get this running so we have a fresh run here. This demonstrates creating a string that has been concatenated with successively iterating characters. And it'll print out capital A through Z as one string. So here's what that does. First of all, we saw ORD is the single character conversion. It'll convert a character to an integer. This S here is just an empty string that we will create, and we will slowly build that string as we concatenate it. And then the next couple of lines are a for loop. We're just going to go for I in range. N is going to be whatever the ordinance or ordinal value of capital A is, which I believe is at 65. I'd have to go back and check the ASCII table. So this is going to go from 65 to n plus 26, or whatever that ends up being, 90, I think 90. So this loop will go 26 times, and every single time it is going to take the ASCII value, let's say it's 80 at that point, and convert that to a character. So that's what CHR sub I is going to do for us. It'll convert this integer to a character and then append that to the string S. And then here we just simply print out S. So pretty straightforward. Again, the burden here is that Python has created some 27 different strings. And if we were to open up the hood of Python and peek deep inside, we would see that these 27 strings, in fact, all persist and exist. And again, we're not going to notice a performance degradation in simple scripts like this, but get into some big data, we'd absolutely see some problems there. So solution to that is going to be using the join method. So here's another script, and let me get this running first. We see that the output is the exact same thing, just the a string containing the characters capital A to capital Z. And what we do here instead is we don't use string concatenation. Instead, we are going to develop a Python list. And that Python list is going to contain all of the characters that we want to ultimately join together. So it'll be a list of 26 characters to start, capital A, capital B, all the way to capital Z. And rather than a concatenation operation happening within this for loop, we're just simply going to append that value, the character equivalent. We're going to just append that to the list, and it's going to, we're going to add another element to the list. And at the end, we will join that list together. So here first is our starting point for n, whatever the ordinal value of capital A is, and that's 65. Here is our list, and we initialize it just to the empty list. Here for I in range n up to n plus 26, that's going to get us 26 times through the loop. And we're just going to append every time through the loop, we're going to append or add an element to the list. And what are we going to add? Well, the character equivalent of I. So if I currently is 70, that will be, what's that, a capital F, I think. And it'll then append a capital F to the list. So by the end of line 4 here, we'll have a Python list with all of the characters in it. Now here is where we're going to use the join method. And this is new, and it's going to be more efficient for us because it's just going to take whatever is in a underscore list and sort of mash it together in one giant string. And we do that just simply using join. Now, what's interesting is this syntax here. Normally we would call a method like .join, we would call that method on an object or some kind of a variable or a string, on something. Here we're calling that on a programmer-defined string that's a literal. And what that literal represents is this is going to be the separator. In other words, if we want to separate items in this list, we can simply put in what that separator is going to be here. And I'll have an example next how we can use a comma as a separator. So here I'm just going to do single quote, and that means that there is no separator. We're going to have a null character be that. And then join is simply going to then just collapse that entire list into a single string and output it, and there's the results there. Now, if we were to say, yeah, okay, I think I changed my mind. I do want a separator there. Then our list becomes, our output becomes this, where we have, and this is again a single string that's named S, and every character is separated by the separator that we programmed in, a comma. Or let's say instead of that, we want a separator to be a couple of asterisks. Well, there it is now, and we've got a couple of asterisks then separating these values. So that's a pretty grinchy little trick. And the join method lets us do more advanced capabilities like this in a much sleeker way. Now, here is another example, and before I go on, let me get this up and running. Here's kind of a cool example. It shows sort of an old school way and a new school way of taking a list that's got 4 elements in it, 4 items, and if we wanted to output that list as a very well managed list with commas and a space between them, so that it displays kind of set properties of commas between these. This first part of our code does just that with our 4 beetles, and it does that in sort of a legacy way by actually stripping off the final comma and space. So let's step through this. This is just a definition of a function. Call it print nice. It's going to receive a Python list. S is our concatenation builder. So we will start with an empty string and just build from there. And then for item and list, this is just going to iterate through that list. Every time it's going to extract an element, and it's going to call that element item. So every time through this list, we are going to concatenate whatever S currently was with two things. One is the item itself, and then we're going to add a trailing comma and a space. And that's going to give us like the Paul, comma, space, George, comma, space, like that. What this does, though, is that it gives us one of these comma spaces too many. It's going to give us 4. So the very final one is going to be Ringo, comma, space. And we don't want that. We only need 3 commas, not 4. What this is going to do is at the very end of this for loop, when that's done, it's going to, first of all, let's make sure that the list is not empty by chance. Maybe the list that we sent that function happened to be an empty list. Well, this is going to just guard against that. This line here, S, is being assigned the string splice of from the beginning to 2 characters from the end. And then it'll do a reassignment that way for the string. Now, make sure that you review that section in the text carefully, just about slicing these characters from a string. If there's no value or no integer specified at the beginning, before the colon, then it's presumed that the beginning element is indicated. And then we can go up to -2. It looks like a weird index, but with Python, remember, if you use a minus index, it's going to just start counting from the end. So this here will actually strip the final 2 characters. And then we can call the function. We'll give it a nice list with the 4 Beatles, and it prints it out there just fine. Now, this is a lot of kind of old school coding. What we can do is use join for this and come up with a lot less coding. So here's the same definition of a function. I'll call it print nice2. It's going to just receive a list, and then it's just going to output that list by joining the members together. Except, look what we did here. We are going to use as the separator the comma space combination. But what join does is it doesn't put that everywhere, it just puts it between the elements that are in play. So it's automatically going to skip that last one. So when we send this list then to print nice2 to that new function we created, we're going to get this exact same output as before down here with John, comma, space, Paul, comma, space, George, comma, space, Ringo. And you'll note that that final trailing comma space simply does not exist, because the join method will only put those separators where there in fact are 2 data elements that have to be separated by something. So I hope this helps with explaining the join method, and I do encourage you to use it. It's a very efficient and well developed method, and it'll absolutely help with your string operations.